Hello, welcome to the 6.2 notes on using proportions to solve geometry problems. In this section, what we're going to do is recognize similar ratios, and we are going to use proportions to find the missing length in a figure. All right, so example 1 here tells us that in the figure below, AB over AC equals BE over CD, and we want to find the length of AB. So all you have to do in a problem like this is set up your proportion the way they gave it to you and fill in all the numerators and denominators. So the first numerator, they want me to plug in AB. Well, I look over here and there's nothing there. So when I don't know something, and that's why I'm looking for AB, but if I don't know something in math, what I call it is a variable, and I usually use X. It's the most popular of the variables. So I'm going to put X in the numerator. Now the denominator, they want me to put the entire length from A to C. So if the top piece is X and the bottom piece from B to C is 6, what I have to do is add those two, and it gives me X plus 6. Okay, on the right side of this proportion, BE is 10, so I'm going to put 10 in the numerator, and then 24 is what CD is, so I put a 24 in the denominator. All right, as with all proportions, I am now going to cross multiply. So X times 24 is 24X equals, when I find the cross multiplication there, I have to make sure that I put parentheses, otherwise you won't get the right answer. You have to multiply both pieces of the denominator by 10. So you get 24X equals, on the right side, 10X plus 60. And let's solve for X. We're going to subtract 10X from both sides. You get 14X equals 60. Come over here, divide both sides by 14. X is going to equal 60 divided by 14. That reduces to be 30 over 7, or 4.3 if you approximate. Okay, so that is how you would do the first problem. Okay, so the next part of our notes is talking about, gives us a definition, a scale drawing, and that is a drawing that has the same shape as the object it represents, and the scale is the ratio that describes how the dimensions of the drawing are related to the dimensions of the object. Back in the day when we used maps and atlases, you could figure out how far more or less you drove, just because every inch on a map would represent 250 miles in real life. Or for those on the metric system, a centimeter would represent 160 kilometers. Okay, so here's another example. An inch on the map would equal 20 miles, so you could look more or less how much you have to drive. And a centimeter would be 13 kilometers. Okay, so example number 2, they tell us that in this, the scale in the drawing below is 1 inch to every 2,800 inches. And we want to find how tall is the Eiffel Tower in inches. So when they give you a scale, they're comparing the drawing to real life. So that gives you a ratio that you're going to use for problems like this. So 1 to 2,800. Now the 1 is the drawing, and 2,800 is real life, how tall the object would really be. And so we want to find the height of the Eiffel Tower and how tall it is in real life. So what you have to do is find one of the values, either the numerator or denominator, fill it in, and solve for the unknown. Well, if we're finding the real life height of the Eiffel Tower, that means I have to figure out the height of it in the drawing. And if I look across, it's about 4.5 inches. Because the 1 corresponds to the drawing height, I have to put the 4.5 in the corresponding spot, so that would be in the numerator. My X value is the unknown. It's the height of the Eiffel Tower in real life. So now I'm going to find cross products, cross multiplication. 1 times X is X. 4.5 times 2,800 gives me 12,600. And this is the height of the Eiffel Tower in inches. Now, if the question, because sometimes you're going to have to change units, if they wanted it in feet, I would have to divide this by 12, and that would give me the height of the Eiffel Tower in feet, and that would be exactly 1,050 feet. So you just have to be careful with these problems. The one thing I would warn you about is units, and if they change units on you, you have to make sure that you do what they want you to do. Find it in the units they want you to. Okay, so example number 3, it says you build a 3D scale model of the Reunion Tower in Dallas, Texas. The actual building is 560 feet tall. Your model is 10 inches tall. And then they say that the diameter of the dome on your scale is about 2.1 inches. So diameter would be the distance across a circle if you go through the center. But we'll talk about that more in later chapters. Okay, so the scale that we're going to use, you have to find two corresponding units. So they said the actual building's height is 560 feet. Your model is 10 inches. So the scale would be 560 feet to 10 inches. Now, because it wasn't specified, should you do model to real or real to model, this would be fine as your answer. All right, so part 3, just kidding, part B, we're going to find the diameter of the actual dome. So 560 feet over 10 inches, and we're going to set up a proportion, so we're going to equal this to something. Now, my numerator here represents real life. The denominator represents my model, so I have to be careful. When I plug in the diameter that I have here, I have to realize or try to figure out, is that the real life diameter or is it the scale? Well, it does say the diameter on the model is 2.1, so I'm going to put that in the denominator, and my unknown is x, so I put that up in the numerator. Okay, at this point I'm ready to find the, I cross multiply. 10 times x is 10x equals 560 times 2.1 gives me 1,176. Divide both sides by 10. And x is going to equal 117.6. And now because this is the real life dome, it's feet. Now notice that my scale, when I did the scale up here, I had two different units, and that's totally fine because then my units on the right, when I set up my proportion, went with it. My 2.1 was in inches, the denominator of my model is in inches, the numerators were feet, and that's totally perfectly fine. All right, moving on to example 4 over here. We are given that the perimeter of a rectangle is 132 inches. The ratio of the width to the length is 5 to 6. Okay, and I have a rectangle, and I know it's perimeter, which is the distance all the way around it. If I add up all four sides, is 132. Now, the ratio of the width to length is 5 to 6. I know for sure that the width is not 5 and the length is not 6, because if they were, the perimeter would not be 132. When you express a ratio, you always write it in its most reduced form. So if I reduce this fraction, or this ratio, I know that I reduced by the same amount, but I don't know what amount I reduced by, so we call that value x. Okay, there was an x taken out of both the width and the length, and that left me with a reduced ratio of 5 to 6. So I'm going to call my width and length here 5x and 6x. So the perimeter, if you remember from chapter 1, you add up all the sides, so 5x plus 6x plus 5x plus another 6x. If you wanted to do 2 times the width plus 2 times the length, that's totally fine. Let's plug in 132 for the perimeter, and 5x plus 6x plus 5x plus 6x is going to give me 22x. Divide both sides by 22, and that gives you an x value of 6. So 6 is not the actual width or length. Remember that the width or length were divided by this value of 6. So if I want to find the width, if the ratio is 5 to 6, I'm going to do 5 times 6, so it's 30 for the width. And then the length is 6 times x, so 6 times 6 is 36. That's the length. And if you want to double check your answer, of course, plug that in. See if 30 plus 30 plus 36 plus 36, does that give you 132? And if it does, then you did it correctly. And it does. Okay, example 5 here tells us that the area of a rectangle is 4,320 square inches. The ratio of the width to length is 5 to 6. So again, width to length. And area is not the same as perimeter. The way you get the area of a rectangle is you multiply length times width. So again, I'm going to just put the area inside. The width to length is 5 to 6 once it was reduced. So we're going to call the width 5x, and the length then is 6x. So if I put those on my rectangle, Remember that area is length times width. So here I plug in 4,320 equals 5x times 6x. Multiplying those out, you get 4,320 equals 30x squared. Our goal is to get x squared by itself, or x by itself, so we're going to divide both sides by 30. You get 144 equals x squared, and then the way you unsquare something is you square root it. So you square root both sides. X is equal to plus or minus 12, but I don't want a negative side length, so it's 12. This is not my answer. They want me to find the length of the rectangle. So if the length was 6 times x, it's going to be 6 times 12 for the length. And that gives me a value of 72, and it's inches. I don't know if in example 4 if I put units, but make sure you put units. If it's just in length or width, it's just inches or feet or whatever it is. Okay, I actually want to go over extra example number 1 because it comes up quite often. It's a very popular problem, I would call it, in this chapter, meaning it's going to show up on quizzes and tests. Now it tells us that the measures of the angles of a triangle are in the extended ratio given. Find the measures of the angles of the triangle. So 3 to 4 to 11 means that the 3 angles of some triangle, we don't know what kind of triangle it is, but if I was to take the 3 angles and reduce them, they're in a ratio of 3 to 4 to 11. So angles, remember, are inside the triangle, so 3 to 4 to 11. I know that they're not 3, 4, and 11 because the 3 angles of a triangle have to add up to 180. So just like with the rectangle problems, we tack on an x, a multiple of x, to all 3 angles, and then if we reduce them, they would be in that ratio of 3 to 4 to 11. So now what I'm going to do is add those 3 angles, 3x plus 4x plus 11x, and a triangle's angles always add up to 180. So I don't need to be given the perimeter. I don't need to be given the area. I know what it is. So 3 plus 4 plus 11 is 18x equals 180. So x is going to equal 10. All right, so if the angles are in this ratio, the 3 to 4 to 11, and I found that they were reduced by 10, here are my 3 angles. 3 times 10, so 30. Then the next one, 4 times 10 is 40 degrees. And then the last one, 11 times 10 is 110 degrees. How can I check that this is right? Well, the 3 angles, do they reduce to 3, 4, and 11? They do. If I divide all of them by 10, that's why x was 10. And then if I add them together, I should get 180. And it is, so I know that that's the right answer. All right, thank you guys so much for watching, and girls, and ask any questions in class if you have them, okay? Thanks.